Hey guys, welcome to my channel and welcome to chapter 12 of the Cross Origin Resource Sharing course. We've come a long way from the start when we were looking at an overview of web applications to the course specification to different aspects, request types, different different implementation techniques in Spring Boot. We played with different setup modes and saw the results we wanted to see. So at this point, like I mentioned in the previous chapter, I'm going to be going into a more advanced one. Maybe it could be simple to some people, or it could be more advanced if you've never really dealt with course or if you're not very clear about how Spring Boot works internally. I hope to cover that here because I usually like to understand things from first principles. I really want to know how things work. So this chapter is completely unnecessary for just being well versed with course. You don't really need to go this far. But if you're interested, like I mentioned, go come on this last part with me and you'll understand the different aspects of how course works on the back end from an architectural perspective. We'll take a bird's eye view of how different components fit in together, both in the course spec, the core specific modules in Spring Boot, as well as the core generic modules, architectural modules in Spring itself that make implementing this specification possible. So this is advanced because it will also give you ideas on how something similar could be implemented because the Spring architecture is quite modular and generic. There's lots of plug and play that you can do, and understanding these increases your opportunities for doing some advanced things in the using Spring Framework and Spring Boot. So there are very many benefits to studying this chapter. However, it's by no means necessary for you to be fluent in solving problems that involve course or configuring a backend for course or just what we devs do on a regular basis. So if you want to go on this with me, let's get started. So we're going to start with an overview of the way I've structured it is that we're going to first look at what are the components on the Spring Framework side or Spring Boot side that make up strictly cross-origin resource sharing. They serve course. They are there because course is the end goal. There are components that are generic architectural components, infrastructure components of Spring Framework that we use to implement course. But I'm going to start from the more specific and concrete side of components that were created mostly to serve course needs. And then from there, we shall move to an aspect of the Spring Boot auto configuration or boot up process. Because during the boot up process, configurations are read, different kinds of beans are put together into the application context, and then so auto configuration happens. Sorry, it happens after all beans are created in the context. When the context is ready, then auto configuration starts. Basically, it's Spring Boot does this to give us sensible defaults to be able to build applications easily. So we're going to look at that part of the process, like the auto configuration part. And then later we shall look at the flows. So after understanding the course components and how they interact, we understand the Spring Boot and the Spring Framework components, the infrastructural provisions within which course fits. And then we shall see how a request flows through the Spring Framework system and how where course is executed. Yeah, so let's do an overview of the course files and components. So basically, just study. I think as I've been talking, you could have been studying the diagram I have on the screen, and basically, I'm going to use this to sort of discuss. the course specific components. Um, yeah, so we've been do seeing the request and response aspects for almost in every video. From the front end, we discussed what an HTTP request is, HTTP response, and we've basically been looking at HTTP requests and responses throughout this series. So I just wanted to place them here so that we remind ourselves that everything starts and ends with an HTTP request and response because, sorry, a client like the browser basically sends a request and receives a response, gives the user what they're looking for, or shows them an error. So we have the servlet request and the servlet response side by side. And we already mentioned that CORS is an extension of the HTTP protocol, which is header based, because most HTTP extensions use the header path to extend the protocol. So CORS uses this by adding some custom headers. We have the request headers being seen here and the response headers. There is no other mode of communication. There is no other mode of implementing cross-origin resource sharing between clients and servers, but strictly through the headers you're seeing. So I just wanted to make sure these ones are clear over here. And then we've also seen that um, the browser sends a request and gets a response. But now the layer we want to go into is sort of from here downwards and to the side. So we can see the request comes through the internet and basically through the Tomcat server or whichever server is being used. And it's ultimately, we can say it ends up at a handler. Every request will end up at a handler that sort of takes it, reads the request parameters, and then serves a response according to the design of the application. And if a handler is not found, then this is where you get a 404, no handler found for this particular endpoint. So here, picture, we have our handler here. And this handler could be any of very many things. Could be a controller method. It could be maybe a filter or an interceptor. Forget about the details. Just know something receives that request. It handles it and sends back a response. All right. So this handler is just a generic placeholder I've put here to represent one of very many options we can use to handle requests in a Spring Framework application. But most common to us is, of course, controller methods. So in your mind, you can picture it as such, or a filter, or an interceptor, depending on whatever you're comfortable with, or just the dispatcher servlet, depending on what you know. But this is something that receives the request, sends back a response. So when it comes to CORS, the handler must have access to two things. After receiving the request, it has the response object, because requests and response objects are passed through the execution chain in Spring Framework and they come back together. The response is returned, but it moves along with the response moves along with the request because through the execution chain, several things can happen. Some headers could be added to the response when it has not yet reached the final handler and so on. So there will always be request and response present along the execution chain. Because one could think that the response should only be present when when the request is being responded to, but right from the start, there is a response object. It could be empty, but it's there. When it reaches the controller might set a status, and then set a response body, but on an object that has been there available in the execution chain. So for course implementation, we apart from the request and response objects, we need two other components. So basically, the handler needs to have a configuration source. All right. So there's an interface called the CorsConfigurationSource, which is in a Spring application, a Spring Framework class. It is Basically, the way you hear the name, it's a source of course configuration. We've looked at this before in the demo about in the demo about course filter. A course configuration source is a source of course configurations. And even when you look at, I've created a subcomponent here, which shows basically what data it contains. You give you give the course, it has a request object. It doesn't really have, but maybe we can start from down here. It is a functional interface that has only and only one method called the get course configuration. Basically, the purpose of this interface is to respond to calls requesting for course configurations, right? So any handler or any object in the Spring Boot context, like the course filter or any handler, can get access to the course configuration source and say get course configuration and pass to it the request object. And then it receives the course configuration the developer should have configured like we were doing before. So it has one method, get course configuration, and this method receives a course, a request object. Maybe I should put this here. It's confusing when I put it together with with the internal attributes of this class. So let me just reduce the size of that. Okay, let me delete this. So basically, the course configuration source typically has a map of path to course configuration. Remember, everywhere we created course configurations, we were either creating it on top of handler methods, which means that we're mapping it to directly on top of handler methods in a controller. That means it's mapped to a path, or we were creating it at the controller level, which applies to each of the handlers, or in the WebMVC configurer. In either case, it is pretty clear to us that a course configuration is assigned to a specific path, right? There is no confusion about that. So when we have our path mapped to configurations, then any object in the context can request for course configuration for any particular path. So when a request comes in, um, when it is sent to the course configuration source, it can basically just retrieve the path from that request and return the appropriate course configuration. So this is the purpose of the course configuration source. And I put here the course configuration object that is eventually returned. And as you can see, it has the same headers as the response. So this is the list of headers that can be set. This is the list of fields in the object. You can picture this as a DTO or a Java, a POJO. Picture it as a POJO with fields like allow origins, allow headers, allow credentials, and all the good stuff, all the fields we saw throughout this course. So it's encapsulated into that object, and the call configuration source returns it when requested for. So coming back to the handler basically needs a configuration source where it can receive a request, then kind of query for the configurations for that particular request path. And if that problem of configuration source is solved, we've been solving that throughout this course. We typically started with no configuration, and then we added something minimal, and then we went on to enhance the configuration, adding different attributes and all. So if the handler has that problem solved, then the other thing it needs is a CORS processor. So again, CORS processor is a functional interface with only one method. Its implementations must expose one method called process request. What are the parameters of this method? It takes a request, a response, and the course configuration. So do you see this, and that are basically going to end up in the handler as parameters and arguments to serve to the course processor. So in the course processor, the process request method takes these three parameters. With it has the request on the one hand and the course configuration or on the other hand. Basically, it has what the client wants and what the server is ready to give. Then it analyzes these two and ends up giving a final response, depending on the type of request. So in this case, the CORS processor's process request method returns one or two results, either true or false. It's a Boolean response type. So what happens is, for example, if it's a pre-flight request, it might decide to it might decide to look at the origin header that's requested and the allowed origins, and then look at different fields depending on if they all pass, then it responds to the response with the course headers. It sets it on the response and returns true. When it returns true, then the request will proceed as normal. When it returns false, the request will fail. And we are very familiar, I think, by this time with the kinds of pre-flight responses we receive and why. So those responses, whether to a pre-flight request or an actual request or a simple request, they pass through the course processor. For pre-flight, it returns the response right away. And then for actual request, basically, or simple request, it basically sets true or false as expected. So when it returns true, the request will proceed. When it returns false, the request will fail. Right. So I think this is a very good overview of the different components that makes up the course processing pipeline. And it's very important to just especially note the inputs to note the course processor and the inputs to it, the request, the response on the configuration source, which gives us the course configurations for any particular path. And the course processor is the one that runs through the rules, comparing the requested headers with the allowed headers in the server, and basically just returns an appropriate response. So at this point, this is all I want you to note as we are going to go to the next section. So just keep in mind the course configuration source and the course processor, because I know servlet request and response are really no brainer or too common to even forget. Yeah, so that's it. And now, next, we are going to look at Spring Boot auto configuration process and the architecture of Spring that makes this possible. And I know at the back of your mind, you already have all the lessons through which we went. We did configurations, tested them out, and all. And at the end of any course configuration we developers do, whether through exposing a course configuration source bin like we did with CorsFilter, or using cross origin annotations across our across our um, across our controller methods and controllers themselves, or exposing a web MVC configurer bin. Ultimately, everything we're doing is to create a course configuration source. Right? We're going to see how this happens. So let's move over to another tab here that talks about the Spring sort of infrastructure and framework. So on the screen, you can see something that looks like, I don't know, maybe a horizontal broom, but I have what I'm showing here is basically how a lot of web applications work. Basically, this is a demonstration of what is called a front controller pattern, which Spring Framework follows. So the front controller pattern is an architectural design pattern that that places one main handler for all web requests. So all web requests from clients, from any client whatsoever, ends up at one central handler. It's this central handler that then dynamically reads the request that has come in and locates another handler that will it delegates the handling to another handler. That handler tells the central handler what the response is, and then it's the central handler that talks back to the client. So this is the front controller pattern. And in Spring, the front controller is called the dispatcher servlet. Remember, the Spring framework is built on top of the servlet specification. So basically, we have clients. There could be many of them. When they send a request, the request first hits the front controller, which is like a clearinghouse or a router. It receives all requests from the outside world. And then when the request lands inside there, it dynamically locates another handler, which it has access to. And this other handler is the one that actually handles the request. It's like a delegate. It handles the request, then returns a response to the clearinghouse, and the clearinghouse responds to the client that asked for it. It's like the receptionist that sort of receives all clients and gets their queries, forwards it to the appropriate office, gets the response, and gives to the person. So this is basically how the architecture of Spring framework is at a very high level. So now in the dispatcher, you can see that we have an object I've placed here, which is a list of type handler mapping. Since I've said that the dispatcher servlet has, I could say, a registry of handler mappings that it dynamically reads whenever it receives a request and locates the correct handler mapping for a specific request and then executes the handler, right? So, as a developer, you can register handler mappings or handlers with the dispatcher servlet, not directly, but through framework features. But whenever you're defining some things, you're registering handlers for the dispatcher servlet to read and and wait for the time when that handler will be required. So just take note of the fact that the dispatcher servlet is the clearinghouse for all requests from the outside world, and it has a registry of handler mappings that it dynamically searches based on the request. And the one that matches the request is going to be invoked and it handles the request. Then it returns the response to the dispatcher servlet, which forwards it back to the user. So one might wonder, so how does this list of handler mappings get into the dispatcher servlet, and what is our role and what does this have to do with CORS? So basically, this section is mainly about understanding the framework features of Spring, and then we're going to see how the CORS aspect fits in. So to understand how this handler gets here, and what it has to do with course or what anything we've been talking about. Let's look at another diagram here. So one thing I should mention before getting out of this diagram is that when you start your Spring Boot application, one of the things that must happen before it starts serving requests is that the dispatcher servlet should be initialized properly. It must have its registry of handler mappings ready. If they are not ready, the application is not ready to start serving requests. And you'll see that line at the bottom saying that application started successfully in 1.1 second or something like that. So these are all preliminary stages. The creation of this registry is key because without this registry, the dispatcher servlet cannot dispatch requests. So business is not yet open if that registry is not set. So if we look at this diagram over here, on my right hand, you'll see a circle I've created, and inside it is the label application context. So ultimately, the Spring framework is an inversion of control container. It's a dependency inversion container. It basically reverses the order and responsibility of to create objects from the developer to the framework. Then, as the developer in your applications, you just request for injections of specific types of objects, and these objects are called beans in the Spring framework ecosystem. So I've drawn this circle with the label application context to represent the application context, and I've tried to paint a picture of We have an application context with so many beans inside it. It could be in thousands. For any non-trivial Spring Boot or Spring application, the application context could have thousands of beans registered in it. These are just Java objects, but that are managed by the Spring framework. So you can see I've labeled a couple of these to give a picture of beans that are just floating around inside the application context. And then there is one particular one I've labeled in green and bolded, and I wanted to draw attention to it. So the these beans, bin one, bin two, and so on, they could be maybe a data source bin or user service bin or a controller bin. Any object you create in Spring that is read during component scanning or that you expose in factory methods in a configuration class end up as bins in the application context. So some of the bins are user created, like the ones we expose through component scan, auto wiring, or whichever way you create bins in the Spring application, Spring framework. Those are user created, but some of them are also framework bins, infrastructure bins. So one of those infrastructure bins is called handler mapping. There's uh, there's an interface of type handler mapping. An instance of handler mapping is always present in the Spring application context. It is created through a different process altogether. However, when the application context is built and ready to serve requests, typically there is a bin there, just like there are bins of data type data source, or maybe JDBC something, or user service bin. It doesn't matter what bin, but handler mapping will probably be among them. All right. So we have looked at this. Now let's move over. We have our dispatcher servlet here. So when the dispatcher servlet is starting, remember I said up here it must have an instance, a registry of handler mappings. So the dispatcher servlet, when it's being auto configured, it queries the application context. I should mention the dispatcher servlet is an application context aware bin. That means that it has access to the application context in a conventional way. It's given the application context to query and to interact with. So when it is being auto configured, it queries the application context for all bins of type handler mapping. Remember, you can search bins by type in the Spring application context. You can also search by name of the bin. You can search by different methods. But in this case, if you search by type, then all bins of a specific class type are going to be returned. But if you search by name, of course, two bins of the same name cannot exist in the context. There will be a clash. Even when you're declaring a bin in Spring like that, there will be a clash and the context will fail to start. So the dispatcher servlet queries the application context for all bins of type handler mapping. All right. So you say, give me bins of type handler mapping, then the application context returns a list of bins of type handler mapping. This is basically where this registry is got, right? So at the startup during auto configuration of the dispatcher servlet, it queries the application context for handler mappings, and then it receives them and puts them in its registry. There, it's ready to start handling requests. Because I mentioned that handler mapping is the registry of delegates that the dispatcher servlet uses to dispatch requests to. It delegates requests to other delegates just that are in the handler mapping. So then the other question could be, someone may wonder, like, if I have a list of handler mappings, right? Then I get a request. Why is the handler mappings not just a map of URLs to the handler? What does how does the application or the dispatcher servlet do this? Isn't it more efficient to just have a map which you query in instant time? So that is one question, and even I could make it more important by asking another question. by stating something else. In a typical, one secret I should tell you, if you're not aware, is that in a typical Spring application, in a simple application, usually this list only contains one object, right? I know that is a bit counterintuitive, but in a simple, basic Spring application, most Spring applications that you're playing around with, maybe not non-trivial one. Let's just say we'll have a single handler mapping object in that list. All right. I know that will disorganize some of our understanding, but it's very important. It's even more important that now I ask the question I was asking. So, what's the point? Why have a list of handler mappings when you're only going to have one handler mapping, right? So, remember I mentioned earlier you can create your own handler mapping, but if you don't, Spring Boot auto configuration, it creates a default implementation of the handler mapping interface and keeps it available. All right. So, what is this handler mapping interface? Basically, it contains all the handlers, right? So, a handler mapping object is not the one that handles the request from the dispatcher servlet, right? Much as it's a list, someone could imagine that, okay, this is a list that has all the handler mappings for all the requests. No, one handler mapping is more likely to have one handler mapping object is more likely to have handlers for all the objects, on the all the handlers, controller handlers, and all in the application context. So that may cause more confusion, but I'm going to clear that in a bit. So whenever you create controllers, whenever you create yes, controllers and controller methods, basically, the controllers and controller methods are considered a class of handler mappings that are called request mappings. So when you're creating a controller, you usually add a request mapping annotation up there, and then you put a path. Then you go to the your maybe get methods, and you add a get mapping, add a path, a post mapping, put mapping, and all. So those mapping annotations are basically subject of a target of a certain handler mapping implementation called request mapping handler mapping. That is an implementation of the handler mapping interface that is going to be returned when the dispatcher servlet queries the application context, if you don't create your own anyway. And creating this is not necessary. This is an infrastructure bin. And I don't think there's anyone, most people will not have created this on their own because it's not necessary, right? Basically, to understand exactly how the course processors and course ecosystem fits into what I'm describing here, let's just have a look at the anatomy of a handler mapping object. So here it is, and basically this image I'm showing here reflects what is contained inside a handler mapping object. So the first thing and the most important thing is a map of URLs to handler methods. So remember there's handler mapping and now there's a handler method. So you can picture that handler mappings contain handler methods. A handler mapping contains handler methods. So one handler mapping will contain all your controllers and controller methods and everything that you use to handle requests in your Spring application. So I have my handler mapping object here. It has a parameter which is a map of URLs to handler methods or path to handler methods. So picture that every time you create a get mapping or a post mapping or a put mapping, you are creating a handler method. So this handler method, so the URL is going to be the URL path to your controller method. So if you have, like we had in the previous demos, API slash course, so the URL here will be API slash course. The handler method will be our test course method we looked at. And this handler method object is an object that contains all details about your endpoints. One of them is the HTTP method. The second is the method name, the fully qualified method name, like with a class name, controller class name dot and the method name appended. And then the types of the parameters that are needed by the method, the type of the response, any extra annotations. Basically, it encapsulates everything about the endpoint you declared, right? So a map of all those handlers is kept in the handler mapping object. Then another very interesting map is also kept in the handler mapping object. A map of handler mapping to course configuration objects. So see how interesting this is, right? It's a map of handler method to course configuration objects. Remember, I said that the course configuration is a very key component for basically without it, there is no course compliance in the server. So a map of handler method and course configuration. So every time we created a cross origin annotation on a handler method, there will be something inserted into this map. Or every time we created it at the controller method, then there will be a course configuration created for each of the handler methods in that controller and put in this map or during auto configuration. And then every time we created a WebMVC configurer, just know that all all endpoints that were targeted in that configuration ended up being here with their handler methods mapped to the course configuration. And where we targeted everything in the Spring application context, basically all endpoints we declare are going to have a map entry here. And then the handler mapping implementation typically has this third parameter, a course processor. We've already talked about what a course processor is, what it takes in and what it does. So the course processor is basically there is a default implementation. You don't need to implement your own. There's a default course processor called default course processor, which is used in most of Spring Boot. But you can implement your own as well and change the rules accordingly, right? But it's not really recommended or it's not even necessary. But if you feel the need to, if you feel a calling to do that, you can try and it will be used. And then when it comes to the methods, the handler mapping has a method called getHandler, which takes the HTTP request and then returns the handler back to the caller. All right. And then it also has another method called getCorsConfiguration, which takes the handler and the request and returns the course configuration. So this interface is very important for us to understand. I think now it makes sense. So if we look at where we started, basically we have a clearinghouse, which is the front controller in the front controller pattern. In our case, it's the dispatcher servlet. It has a list of handler mappings. Typically, this is just one handler mapping. And for simple applications, if you've not defined the handler mapping explicitly, there will just be a default one. But you can also override this by declaring your own handler mapping. And I've already given you the interface of a handler mapping. Excuse me. Which should make it more intuitive. So it acts as a clearinghouse to all the handlers. And the handler mapping object has a get handler method, which is called by the dispatcher servlet when it receives a request. It calls the get handler by passing the request, HTTP request to the handler mapping. Then the handler mapping returns the handler for that request. And basically, the dispatcher servlet delegates the request. All right. And I hope this is clear. We've talked about the front controller pattern and how Spring Framework and Spring Boot is structured, how it works with delegate handlers, and then how those delegate handlers are created and bootstrapped, and what their structure is. And I think somehow you can fairly start picturing like how CORS fits in here, because then I said ultimately we need a state where we have the course configuration and the course processor. So if the handler mapping has the course processor, it also incidentally has the course configuration because it has a map of handler methods to course configuration, just like it has a map of URL to handler methods. So effectively, it has a map from URL to the course configuration. And since the URL is held inside the HTTP request, that means using this request, you can locate the course configuration. And the fact that it has the course processor If you have the configuration, you can feed it to the processor along with the request, and you get the course implementation. That means basically the dispatcher servlet is able to execute course configurations inside itself by locating the handler mapping, getting the handler, and then making sure it calls the processor, right? So keep these pictures in mind. And now we're going to go to the last part of this chapter by walking through the actual request flow. What happens now in concrete terms in the during the request flow. So I'm going to open this other flow. So just study this flow a little bit, and I'm going to start by I'm going to start explaining it in a minute. So I it's this is the diagram that puts everything together, and I also I personally find it very interesting and intuitive because it just gives me a picture of whatever happens inside the application context. So we are going to get started from here. If you look at the components on their own, we have, I mentioned when we were talking about the course filter that when Spring Security is in the path, we have a filter chain there's also a security filter chain in the filter chain. You don't only have a filter chain when there's Spring Security, but I mean, we talked about that and the challenge with executing pre-flight requests. So here is our dispatcher servlet. All right, let me bold it a bit. So here is our dispatcher servlet, and uh, ignore everything else, much as you may be understanding it. This is where the dispatcher servlet is, but the request first goes through the filter chain before reaching the dispatcher servlet. And we explain the challenge with the putting the filter chain before the dispatcher servlet. Pre-flight requests are not credentialed requests, so they will never make it if we don't intervene. Because the when Spring Security is in the path, it is going to block any request that is not authenticated, mostly anyway. And even if you have authentication, the pre-flight request is sent by the browser, and the browser does not attach, according to the course specification, the browser does not attach credentials in the pre-flight request. So we discussed that at length, and we discussed how the course filter comes about. Then we've talked about the dispatcher servlet and how it works with the handlers and how it has handler mappings. And we also talked about this diagram, though in that case we had a dispatcher servlet here querying for handler mappings. So now let's try and trace request from here. Let's first deal with the case where there is no filter. All right. Let's deal with the case. Assume that this request comes, and instead of passing through a filter chain, there is no filter chain, and it goes direct to the dispatcher servlet. We've just been discussing this. The dispatcher servlet has a list of handler mappings inside it. These handler mappings are created from a collection of all your controller handlers, which are put together as a map of path to handler methods inside the handler mapping. And when you call get handler, when the dispatcher servlet calls the get handler method on the handler mapping it has, because I mentioned it typically has only one handler mapping in its list. I explained why. So when the dispatcher servlet calls the get handler method on that handler mapping, what I didn't mention, because I said the handler mapping returns it returns a handler. However, what I didn't mention is it actually doesn't return a handler object itself, because we saw the handler mapping contains a map of path to handler methods, and then a map of handler methods to course configurations, and then a course processor, and then yeah, basically a lot of other things also. So what the handler mappings get handler method returns is something called a handler execution chain. All right. So even if it has only a single handler method, but the framework is designed in such a way that it returns a handler execution chain. So what is a handler execution chain? It's simply an object that contains a handler object, which is what we were thinking before is returned when you call get handler. And then it has a list of what is called handler interceptors. So when you're building very simple applications, you may picture that requests are handled linearly. A request comes from the browser, goes to your controller, then response is sent back. However, so many things happen in between. For instance, someone may want to say, when a request comes, I want these requests. I want to add some custom authorization logic to every request that matches this criteria, or I want to add observability or like instrumentation, gather some metrics without having to bloat my application code with all this. So I want to centralize some bit of actions or set some callbacks in the framework itself, such that every request that comes can sort of do these things, these side effects, without me having to deal with them and without them having to pollute my application code. So the handler execution chain contains one, the handler itself, your controller method, and a list of zero or more handler interceptors. So handler interceptors, you can think of them as callback methods or like just pieces of uh, it's methods that are invoked that have access to the request object and the response and all, and basically they just return true or false, right? If they are successful, they return true. If they have failed, they return false. So you can add some common checks along the path of execution, and your the dispatcher servlet will know what to do. So this is typically how a handler interceptor works, and now I'm going to show you here. So the handler interceptor is an interface. It's an interface that has only one method as well. It has a method called pre-handle. Okay, so the idea behind these interceptors is that when a request comes, the dispatcher servlet now has the handler object to invoke. However, it will first invoke all the list of handler interceptors. It will invoke their pre-handle method. So in a way, it's saying, okay, before you call this request, first call these interceptors of the request. If any of them returns false, don't proceed to call the handler method. This is where you can plug in things like some bit of authorization or centralized utilities that you don't want to put in application code. So for our purposes, we will wrap our CORS processor in a handler interceptor. Do you see how it fits in? First of all, we've talked about the fact that the dispatcher servlet calls get handler on the handler mapping object, and the handler get handler method doesn't return a handler object. It returns a handler execution chain. That means it picks the handler object from the map we looked at earlier, a map of URL to handler methods. It picks the handler, then it looks for all the handler interceptors assigned to that handler, and then it adds it in a list of interceptors. Then all this forms an execution chain. The list may be empty, all right? In which case, there's only one handler object in the handler execution chain. So when this is returned to the dispatcher servlet, basically that is an opportunity for us to insert the CORS processor. The CORS processor, therefore, is treated as a handler interceptor in this architecture. So in Spring Framework, in Spring Boot, whenever we create our configurations on course cross origin annotation, the web MVC configuration, basically after all that is collected and we have a configuration source, then that configuration source contains the mapping of URLs to configurations. When the handler mapping is created, it has access to the configuration source, then it gets those mappings and keeps them available, right? So when we get a get handler call, the handler mapping returns what is called a CorsInterceptor. which contains a course configuration, right? So DispatcherServlet will have access to this handler execution chain, and before invoking our actual method, it first calls the pre-handle, and the CorsInterceptor will basically either accept or refuse this request. So this is one thing you should have in mind. And basically, I really hope it fits very well with the explanations we've looked at before. The fact that a course interceptor is a handle interceptor type, and it has one method, pre-handle. When that method pre-handle is called internally, the course processor is invoked, right? It's invoked, and all the other things we talked about, what happens inside the course processor, it takes the request, the response, and the course configuration. Basically, it does the magic and returns a response. This is how we were receiving all our responses on the front end to pre-flight requests, simple requests, and actual requests. So and that is it from this angle. And now, after finishing this happy path, let's go to the flow where Spring Security is in the path. And we have the request this time will not make it to the dispatcher. It will stop at the course filter. Just think of a pre-flight request only. Now, I had mentioned earlier the course configuration needs the course ecosystem in Spring Boot needs at a minimum the course configuration and the course processor. So the course filter already has a course processor. Reason being, it can just create new default course processor and have it there. However, what it doesn't have is the course configuration. How does it get the course configuration? We know how the dispatcher servlet gets the course configuration, right? It gets it from the handler mapping, which collects it from the URLs, from the WebMVC configurer and the controller methods. But how does the course filter get this? So I want to introduce you to another class called HandlerMappingIntrospector. And you can see this part of the architecture looks familiar because when we're looking at the front controller pattern, we put dispatcher servlet here, which queries the application context for handler mapping interfaces. Which handler mapping is this one that contains all course configurations and all handler methods? So clearly, this should show us that from this leg, this object called HandlerMappingIntrospector has access to the application context, and it is also querying the handler mapping so that it has the same information as the dispatcher servlet at the beginning, right? But the question is, why doesn't the course filter just get the handler mapping directly? So the problem is that the filter does not have exactly the same view into the application as the dispatcher servlet, right? So handler mapping introspector is a framework being created by the Spring folks to help filters and any pre-dispatcher servlet component to have a look ahead mechanism to be able to look into the future of this request. How will this request be handled by the dispatcher servlet? What are the parameters that will be considered when the request is finally handled so that they can do some things they would like to do that need knowledge of how the request will be handled? So the handler mapping introspector is specifically for introspecting handler mappings. You can even see from the name, the target is handler mappings. The action is introspection. Look into the handler mappings that are going to be used in the dispatcher servlet when the request finally reaches there. Now, for our course filter, it needs this information. What are the configurations that have been made on each of the handler mapping handlers that will eventually handle this request? It needs to understand what is configured down the path, downstream, what is configured, so that it can make decisions in the now about the request. So in this case, it receives a pre-flight request and it has to make a decision on what needs to happen, right? Whether to accept or reject, what headers to set and all. So the handler mapping introspector is the bridge between the filter and the handler mappings. The dispatcher servlet has it in itself. It's actually a field in the dispatcher servlet, but the handler mapping, the course filter doesn't have access to this. So through the handler mapping introspector, which is a bin in the context, the course filter can query the handler mappings in the bin and be able to locate the handler mapping for the request it's handling, and all it needs from it is simply the course configuration. Because we mentioned there's already a course processor inside the course filter. So it just needs the course configuration to close the loop, right? So the moment it has the course filter, the course configuration, and the course processor, basically you know what happens. It invokes the process request method with the request response and the course configuration. And then the rest is the same, right? So, and remember also when we talk to the course filter, we mentioned that it goes through different stages and it tries different options. For example, we first check if there's a course filter instance you've created in the application context on your own. Like we did, it uses that if it's there. If there's no instance, it checks if you've exposed a course configuration source in the application context. If it's there, again it uses that. If it doesn't find it, it goes ahead, right? Until when it runs out of options, then it uses the MVC web configurer or the cross origin annotations, all of which end up in the handler mapping, as we've already seen. So this is like the situation where you just have a course filter and you don't have any course configuration source or any other setup. Then this bridge will be used to get the course configurations and the request will be processed as we've already seen. Yeah, so this is the end of that explanation. I really hope I've been clear enough. It's a very dense concept, but I'm hoping that you've understood. At least your understanding has increased. Feel free to watch it over maybe two times or three times, because these concepts can be very confusing. But take your time, and I hope you benefit something from it. And I'll stop here. Thanks very much for your attention, and thanks for following this course. If you like what you've seen, just look out for more content like this coming up ideally on a weekly basis. So cheers. Thank you very much.